Okay, we've got some data to look at. Let's talk about MapReduce and how it all works. What's a mapper? What's a reducer? How does it all fit together? What happens in between? How does it actually analyze my data? And what code do I need to write to actually extract meaning and make this MapReduce job do what I want it to do? Let's get started. Okay, so let's try to explain how MapReduce works in the context of the example of that data we just looked at from the MovieLens website, from the GroupLens data source. So again, mapping in MapReduce just converts your raw source data into key value pairs. It extracts the information you care about from the source data in a distributed manner and maps it to a key value database. And that'll make more sense when we look at a specific example here, but at a high level, it's just parsing your input data and outputting this thing is associated with this other thing, and so on and so forth. So let's take a closer look at the MovieLens data. So again, the format is user ID followed by a movie ID followed by a rating for that movie and the timestamp that rating occurred. So every line, every row of the input data is going to represent one user rating one movie. And obviously, one user might rate multiple movies, and one movie might be rated by multiple users. So just for the sake of example, let's say that we want to count up how many movies each unique user actually rated within this data set. So in that example, the key we want to extract is the user ID, and the values associated with each user ID will be the movies that they watched. So again, the job of our mapper in this case will be to extract user IDs as keys and map them to movie IDs as values. So as an example, our mapping function might take this input data and it will come across the first row and say that user ID 196 rated movie 242, user 186 watched movie 302, 196 shows up again, and this time they watched 377, and then user ID 244 watches movie number 51. Now there's again another file that maps these movie IDs to actual names of movies if you want to go look them up, but just to keep the data compact, they've been mapped to these movie IDs instead. So again, we're trying to answer the question, how many movies did each user watch? So our mapper is going to extract every movie watched by every user. And the MapReduce job will later make sense of that and consolidate it all together. So the job of our mapper, again, is to just extract and organize what we care about. User ID 196 watched movie ID 242, 186 watched 302, and so on and so forth. And it's okay that the same user ID shows up multiple times in this data set. That's expected. Now what happens next in MapReduce is a little bit magical. It happens under the hood. It will sort and group the mapped data for you automatically. So what it will do is take all of the output from your mappers and stick together all of the values for a given key. So you can see in this example, user ID 166 only watched one movie, 346, but user ID 186 watched three movies, 302, 274, and 265. So this data all gets organized before it gets sent to your reducer. It basically consolidates all of the values that were associated with each unique key. And in our example, the values are the movie IDs and the keys are the user IDs. So user ID 196 watched movies 242 and 377, even though these came from different rows of the input data and potentially from even different machines that mapped that data for us. That's what MapReduce does for you. It consolidates all those values together. And then it sends each key to a reducer. So a given reducer machine will be responsible for processing a given set of keys, and it can do whatever it wants to all of the values for that key. So in our example, if we just want to count up how many movies each user watched, we can imagine there's some function called length of the vector of movies that gets passed in, and that's all our reducer would do. So the output of our reducer for each key would be the user ID, 166, just flows through, and then the count of the number of movies that came in. So user ID only watched one movie, 186 watched three movies, 196 watched two movies, and 244 watched one movie. And that is a real example of MapReduce. It is that simple. Take a look at it all together here just to make a little bit more sense. So again, we start with a set of input data, where the input data represents a user watched this movie, rated it this value at this time. Our mapper function, which may be distributed amongst many computers that are responsible for different sections of that input file, will extract the key and value pairs from each line. So for the first line, it will extract that user ID 196 is the key and watched value 242, the movie ID. Again, user ID 186 watch 302, and so on and so forth. Under the hood, MapReduce will then sort all of those unique keys and group together all the values for each unique key. So it will consolidate all of the movies watched by each individual user. 166 only watched this one movie, but user 186 watched these 3 movies, for example. And finally, this is what gets passed to our reducer. So a given reducer will be responsible for a given set of keys, and it will receive all of the values for that key. And our reducer in this example just counts up how many movie IDs, how many values there were, and the final output in this case is user ID 166 watched 1 movie, 186 watched 3 movies, 196 watched 2 movies, and 244 watched 1 movie. And that is a real MapReduce job in action. At a conceptual level, that's all there is to it. So that's MapReduce at a conceptual level. Not really that hard, is it? That's all there is to it, really. I mean, there are much more complicated things you can do with MapReduce. You can chain MapReduce jobs together to do more complicated things, but we can save that for another course. The basic concepts, though, that's all there is to it. So let's dive into some actual code and actually make this even more real.